Hello, my name is Masayuki Nagao. I'm a member of National Institute of Advanced Industrial Science and Technology. Today, I would like to talk on oceanography and sediment fluxes related on biodiversity and ecosystem settings. This is general circulation in the Northwest Pacific. The Northwest Pacific subtropical gyre is the one of the largest biomes on the Earth, covering a semi-enclosed surface area of about 2 times 10 to the power of 7 square kilometer. And the gyre moves clockwise and comprises four prevailing ocean currents, such as the North Pacific Current to the north, the California Current to the east, the North Equatorial Current to the south, and the Kuroshio Current to the west. And locally, dispersion and settling of particles and the benthic fauna succession are closely related to the physical oceanography. This is a representation of potential physical biological forces around seamounts. On the other hand, acoustic Doppler current profiler, so-called ADCP, is commonly used to obtain vertical profiles of velocity in 2 or 3 dimensions. However, it is more difficult to measure water velocity in the abyssal zone than in coastal zones for the following reasons. 1. Insufficient acoustic backscatter due to low density of suspended matter or backscatters. And second, difficulty in detecting slow abyssal velocities. So the purpose of my physical oceanography study is to examine physical aspects of the reliability of velocity measurements for 1 year by the ADCP on JA02 seamount, so-called Ramon-Gyo. And the second purpose is to compare the ADCP results with second version of Japan coastal ocean predictability experiment, so-called JCOB2, the analysis velocity data. And this is study site and Japan's exploration areas for cobalt-rich ferromanganese crusts. JA02 seamount Ramon-Gyo is located off southeastern Minami Torishima Island, such as like this. And this is time series of velocity detected by the ADCP in December 2011 on the top of JA02 seamount. Please note that this velocity data is not the raw data, but the 25-hour moving average data in order to reduce tidal components. As you can see, basically the adjacent velocity layers have similarities of velocity vector. And this is the power example of power spectra of eastern velocity of ADCP. As you can see, high energy concentrations were clearly identified at semidiurnal 12 hours and 24 and diurnal periods 24 hours, such as like this. And the velocity power spectra in the high frequency zone around here differed among the layers. It is possibly because of low amounts of suspended matter in the abyssal zone. But in the low frequency zone around here, the spectra were almost the same. Thus, the low frequency velocity component detected by the ADCP seems to be reliable. And this is comparison of ADCP velocity data with Jacob's reanalysis velocity. As you can see, overall, the ADCP velocities correspond reasonably well to those in the Jacob's reanalysis data. And this is net primary production, NPP. We took monthly average NPP over a 17-year period at 4 locations around 3 seamounts of the Japan's ISA licensed exploration area. The estimated NPP varied seasonally at all 4 stations. The seasonal fluctuation range and pattern were almost identical between the 4 locations. NPP maximums were observed during early spring blooms from February to May. On the other hand, NPP minimums were observed during summer and autumn from August to October, and the values were consistent with the range of NPP, which have been estimated around the North Pacific subtropical gyre using the satellite data. And this is sediment fluxes by sediment traps. The early spring bloom observed by the satellite observation in the previous slide may be related to broader and lower amplitude peaks, such as like this, in total max fluxes of sinking particles observed around April in sediment traps at JA02 seamount. In addition, a distinctive sharp peak of sinking particle fluxes in late summer at all trap experiments at the JA02, JA04, JA06 seamounts. This seasonal pattern of the particle flux was inconsistent with the results from satellite data analysis, where the NPP minimums were found in late summer. We think it is possible that the late summer peak of total mass fluxes observed in this study reflects short-lived or subsurface blooms induced by passing typhoons that were difficult to detect by the satellite images. That's all. Thank you very much for hearing my presentation.